All right, everybody, welcome, welcome. We are live. My name is Marco, and I am back for another session of learning Kubernetes. Now, I'm going to start this session off with just a bunch of excuses. I was saying in the previous stream, if you were here on April 30th, that I will be taking KCSA, the Kubernetes Cloud Native Security Associate exam, today. Unfortunately, that didn't pan out. So life and work and everything comes and you know makes a little bit of dent in your plans, and that's what happened to me. Sorry about that, but I am scheduled to take this in 2 weeks, so I had to move everything by 2 weeks. Not only that, I will be seeing anyone who's attending the Red Hat Summit next week, Monday and Tuesday. I'll be there. So, yeah, that's going to be an extra thing. If you want to meet in person, I will be there. Just reach out to me on LinkedIn. Always happy to meet any of the community. So, today, what we're going to talk about is what I've learned so far about the KCSA, what I've learned to be the most important things in KCSA. And then I'm going to actually take you through the app that we started building last time. I just essentially asked Claude to write a exam prep capability, and it came up with something for sure. Not that it really worked, so I had to do a bit of tinkering, and also I had to review all the questions, and they look really good. So what I've decided is that I am making this app available to the public, and I want your help. If you're learning, if you're studying for any of the Cubestronaut exams, any of the 5 Cubestronaut exam, KCSA, KCNA, CKS, CKA, and CKDA. Whew, I think I got them all right. Maybe I didn't. Do feel free to contribute, because I'd really love to actually see what's going on. I'd like to see where you're getting stuck and where you would need help, and we can build more features. I can only think of what I need help with, and that's probably the command line part. Is the challenges are the big stickler for me, because I really just don't have enough experience in that, and I need to build my experience just working with Kubernetes, breaking it as much as I can. So let me know if you want to help. I would be super, super excited if anybody would be willing to try out, commit their time, a little bit of their time. You're welcome to use any AI tool to build features that you want to build. But really, what I want to do is I want to build this into a one-stop shop for exam prep. First for Kubernetes, for Kubestronaut, then perhaps next step would be Golden Kubestronaut, and then other features. I think there's a lot of potential in this, and I think if we put our heads together and do a little bit of work, we could build a really cool exam prep tool for a bunch of different types of exams, which still are important to this day. All right, that's my excuses of the day. Let's talk about the KCSA. What is the KCSA? Kubernetes Cloud Native Security Associate. Essentially, an exam that validates that you are ready to start your cloud security career. You know enough to become an associate, to start learning. That's a very interesting kind of certification to have. Pre-career or early career kind of certification, where you're really eager to be a security engineer at some point, a security sort of operator, on the response team, in a network operating center, on call, stuff like that, dealing with just validating applications, compliance, that they conform to all of your governance policies and approaches. This is the exam to start with, and this is the exam I'm starting with as well, because I believe that if you want to have a good foundation on any platform, you should start with security. um, from this, I would say I would recommend anybody, whether you're a developer, whether you want to be an admin, whether you want to be any kind of specific role inside of Kubernetes, I would say KCSA is where I would start. This is where I am starting. KCNA, obviously, that's the other one. So if we just go back quickly and we go to KCNA, the native associate, it's just foundational knowledge of Kubernetes, of cloud native capabilities. All right, let's go back and overview what this one is. So essentially, when you sign up, you have 12 months to take the exam when you buy it. Right now, 40% on bundles. This is the discount that ends today. This is what the Linux Foundation is running right now. So if you want to get one of those bundles where you have 2 exams or an exam prep course and an exam, they're 40% off. So do it today. If you're live here, then you're gonna see this. If you're looking at the recording, unfortunately, right now, this is the promotion right now. All right, yeah. So you can also get the Thrive One annual subscription to get access to all kinds of different learning products in there. So yeah, here we've got some free courses, free intro, free Cloud Native Essentials, free container, and then again, it's going to be the link to the Thrive One capability, right? So a little bit of benefits of KCSA. Security is going to be a skill that's still going to be valid for quite a long time, for years to come, regardless of what we're using to develop, what we're using to administer, what we're using to design our solutions. Security is still going to be something that somebody needs to ride off on. Even if we develop fully with AI, if we manage fully with AI, security is going to be the last one that's going to be fully automated with AI. There's going to have to be somebody to sign off, somebody to take the responsibility if things fail. So a lot's going to be running on a security career in the future, for sure. Yeah, so KCSA basically introduces you to not just Kubernetes, but general security principles that you can take and apply to other solutions, to other vendors, to other platforms, to cloud. These same security principles apply in cloud. So what are these security principles? The breakdown of the exam, let me just open this up all the way. We'll go and expand them. The 4 C's of cloud native security. So 4 C's of cloud native security, you got your cloud, the first C, your cluster, your container, and your code. Your deployment can only be as secure as the most broadly sort of secure platform that we have. It depends on the security of your cloud, of your cluster, how you design your containers, and then of course how you write your code as well. And each of them has dependencies. And then of course there will be deeper questions about the cloud, the frameworks and controls that you can use to ensure security in all of these 4 layers, all of these 4 C's of cloud native security, how to do image security, how to do workload and application code security. We have to remember that when we're deploying in Kubernetes, we're always deploying from images. Those images are getting created from potentially other images, from potentially third-party resources. So we need to have a very, very clear understanding of how that image is built and what is inside of each of those images, because it's quickly can be a problem. Cluster component security. So how to secure all of your cluster components, how to secure the API server, the manager, the scheduler, your configuration database, your pods, your container, networking, clients, etc. How to use encryption and storage. All of those are important, and again, applicable to the rest of the rest of tech. Same principles apply. If you want to make sure that everything is secure, you need to put good policies in place. If you want to ensure that your containers are secure, you don't give them elevated permissions privileges, you run them in restricted mode as much as you can. Securing your configuration is key. Your etcd holds all the configuration. Your nodes will compare against the configuration in etcd. And obviously, if somebody can break into etcd, they can deploy whatever they want onto your cluster. And of course, storage security, we need to make sure that we're using encryption on storage. There's no reason to not use encryption anymore. And what I like to do is I like to talk about encryption from the start. When you deploy something, put encryption in place. Even if it's a proof of concept, put encryption in place. Why? Well, because when we don't put encryption in place and we start using something, we're going to be saying like, okay, so I got this proof of concept Kubernetes cluster. I'm going to see how it works. And then that proof of concept is really successful. It rolls into kind of like a validation environment, maybe even into production. And then 2 years into production, you realize, oh, you know what? We never enabled encryption. We're totally not compliant because we didn't encrypt our storage. That's why encryption for encryption at rest, I would say start with encrypted volumes for everything. Don't use unencrypted volumes. There isn't an overhead. There used to be an overhead for encryption. Back in the day, 25 years ago when I started, HTTPS wasn't really that common because it was heavyweight. It demanded a lot of the processors' capacity, power, compute power. There wasn't a lot of encryption at rest either. The AES standard was barely defined at that point. If anything, people were using DES or 3DES at best. So yeah, things have changed a lot. All of these encryption capabilities are now part of processors. Modern processors will nearly transparently encrypt and decrypt traffic. Nearly transparently. We're talking about microseconds of latency, up to maybe milliseconds of latency for encryption and decryption operations. So that's something to consider. That's something to consider when you're installing your own computer. You're installing your operating, you're starting your Linux on your computer. Did you encrypt your volume? Think about it, right? You're storing your passwords, you're storing some documents that you don't want people to have. Use encryption. If nothing else, it'll get you kind of used to it, that all the volumes are encrypted. Don't lose your security keys. That's a good practice as well. Practicing where to store security keys so that we don't lose them. All right. Kubernetes security fundamentals, pod security standards. Pod security standards is the replacement for pod security policies. Essentially, it allows us pods to run in obviously fully unrestricted mode at the root level, or fully restricted mode, or base security mode. So yeah, make sure to understand how pod security standard will affect the running of your platform. And remember that when you're running pod security standards, just opening everything up because it kind of didn't work when it was restricted is not a good policy. Use least privilege. Give only the permissions that the pod really needs. Don't just give admin to everybody. That's like common sense at this point, but people still do it. So yeah, authentication authorization, how does it work? Role-based access control in Kubernetes. As you give somebody a role, they get some kind of access. And you need to understand the relationship between the role and the policy that is applied to that role or standard. How to manage secrets. Kubernetes does have internal secrets management. And of course, you can also externally manage secrets as well. So that's something that you need to be kind of familiar with. Isolation, how to isolate different cluster components, portions of the cluster, how to build network policies, how to audit and log, how to log and audit those logs is what I wanted to say. Yeah. chasing down 3DS and RC4. Yeah, those were the days. Those were the days. Or even chasing down unencrypted stuff, which has been more recent in my career. Even, let's say, in the last 10 years, I've chased down unencrypted stuff as well. Yeah, thanks for that comment. That is totally true. That is totally true. All right, Kubernetes threat model. Um, Trust boundaries, where pods trust each other and can communicate with each other and perform activities. How nodes talk to the control plane as well. Where is that trust? How do we handle persistence? Where the volumes exist. Um, and then, of course, different types of exploits, attacks, threats, denial of service, what it means, how to avoid it. Always put as many barriers in place. I like to build an onion. Security is like an onion, right? The more layers the onion has, the more layers the attacker has to peel. And when the attacker's peeling the onion, the attacker will cry. And at some point, they're going to give up. So basically putting in place all the types of security that you can, your firewalls, your policies, and at the end of the day, making sure you can um, absorb the traffic if need be. The last line of defense is, absorbing that denial of service attempt, because they're going to get through all the barriers. They're going to give you valid requests, but so many valid requests that it's going to get overwhelmed. They're going to try to overwhelm your pods. So scale out the pods, accept those requests, respond to them, and then start slowly, limiting the requests coming from those origins that you determine are attacks. Malicious code execution, compromised applications, those can happen. There are many vectors of attack for malicious code and compromised applications in containers. Like I said before, when you're running on Kubernetes, you're building images, and those images might be built from source images, from source code, from third-party libraries that are included in that, and there's a potential for compromised applications. How do we detect malicious code? How do we identify attackers? How do we ensure that even if the code isn't, if the container is compromised, we can isolate it and remove access to any kind of sensitive data. Privilege escalation attacks, we need to understand what those are. And then we move on to platform security, supply chain security. And this is what I'm talking about. This is about how your images are created, the supply chain, the software supply chain, where we're pulling from multiple different components, we're assembling them together, how those images are being created, ensure that you have clean, lean, fast build images, ensure that you're checking those images as you're building them, ensure that you're building all the right components to capture metrics and logs and do proper observability and tracing across your containers. How to ensure secure communication across your containers, public key infrastructure, also connectivity, admission control. Those are important factors. And then finally, compliance and security frameworks, right? What compliance frameworks exist out there? What threat modeling frameworks exist, like Stride and stuff like that. How to ensure supply chain compliance, and how to use automation and tooling to do that, to do all of that. We want to use as much automation for security, because running something manually is inherently insecure. So when we're talking about compliance security frameworks, we're also going to be talking about how to apply that security. What are the steps to apply that security, or what are the results of a step, of an action that we take? So a lot of the questions that I've gone through, that I've seen so far, is what are the actions? We took this action. We gave, we elevated permissions of a container. Something didn't work, and we elevated the permissions. What are the results of this action? That's the kind of question which essentially validates your understanding of, if I do X, what happens? I think that's a key factor when we're looking at security. We need to understand what we're doing. Um, when it's admin, when it's working with the platform, we need to make sure that we're working in the scope of we're not breaking things. But when it's security, I feel like we need to be even more proactive where we're thinking about how our actions might affect the security posture of our environment rather than, oh, okay, let's try it and see if it breaks. With security, you kind of can't do that. Now, there is DevSecOps where you can break things. The DevOps principles are designed around breaking things and seeing how it breaks and then fixing it. That's why I love DevOps, because I break things all the time. And as I've already pointed out probably multiple times, I'm going to say it again. You don't learn much if you don't break things. Why do I say that? Well, when things go right all the time, what are we learning? That everything we do just works. When things go wrong and we try to understand why they went wrong, then we learn why they went wrong, and then we stop doing that same mistake. And that is a reality, whether it's in DevOps or in your own life as well, right? That's how we humans learn. We need to break things. So with DevSecOps, breaking things is a given. So when you are trying to implement something, go use your standard DevOps practices to try to see what happens when you change something. Go spin up a test environment, change your security policies, run your application tests, security tests, compliance validation, and see the results. That's a good way to learn. That's a definitely good way to learn. That's probably something we should include in the future release of my Kubernetes exam app test exam. All right, let's take a look at the Kubernetes test exam app that I've created. So basically, it is right here. I'm going to put it into chat. All right, this is available for all of you to take a look at. It is version 0.02. So essentially, really, really early days. But essentially what we have is right now it's just terminal. Inside of the terminal, you will have the ability to either answer questions or have a challenge. We're going to take a look at how those work. Linux or Mac, just install Rich and then run the Python file. For Windows, there was an UTF-8 coding thing that broke the whole thing, and I fixed it in the code. But you need to declare UTF-8. So I've got just a batch file that declares UTF-8 so that it works. What's inside right now? KCSA is the only one. 40 exam-style multiple choice questions with detailed explanations. That's a way to learn, right? So even if we get it wrong, we get the response, hey, this is wrong, and this is why you would want to pick the other answer. The idea here is this is a learning tool. This is not an exam to test yourself yet as of this part. This is more of a learning exam thing. All right. 10 hands-on Minikube lab challenges. So basically, you go and you have to do something. You have to actually do something on Minikube or kubectl on whatever platform you're running. If you're running your Docker Kubernetes deployment, then you can do that as well. So yeah, right now these two modes and a few questions from each of these domains. There's no labs for these. There's no labs for cloud native security. There's no labs for threat models because obviously those are not really things that we'll do. But it would be cool if we could come up with, this is a threat actor. Like spin up this container. It's a threat actor. How do we isolate it? At some point, maybe at some point. So yeah, basically you wanna have a Minikube kubectl. That's the minimum, and then in the future, as I kind of learn more about this stuff, and like I said in the previous previous episode, I'm still learning. I have very little experience with Kubernetes, and right now, perfectly honestly, not confident that I can pass any of these exams. This is the learning tool that I'm building for myself, and as I build more features into this learning tool, it's going to be better. And if you want to learn with me, go ahead, clone the repo, you know, uh, fork it, build stuff into it, submit a PR, and we'll build it better. We'll make it better. It's early days, like I said, but I think this has potential. Perhaps it's not the only kind of thing out there. I've looked on the internet. I've even shared in the previous episode a link to a similar kind of thing where it's a web interface that's got questions and answers in there. But yeah, that's essentially what we're gonna do. All right. So let me run this. Let me run this, and we will see how this works. Let me just quickly switch my screen onto the right application. Okay, here we are. Here we are. So this is the same app as we see, is same README. Um, Pretty easy to run. You got your components, and then I just need a terminal. And let me just make sure that it's only one terminal right there. Run. That's it. That's how it runs right now. I'm on Windows. If you're on Linux or Mac, what you're going to do is you're just going to run the Python file straight out of Python. All right. These exams are in, but they're not working right now. So obviously, the only option to select is one. So select one. Exam practice. Do we want to have multiple choice questions? Do we want to have challenges? There's domain breakdown as well. Just throws out the information. Let's go exam practice. Which domains do we want to practice on? All domains. We want to practice on all domains. How many quick questions? Quick 10, quick 5, standard 10, full 20, or all questions. At this point, this is because I need more questions. And questions obviously are right in there. Questions JSON. You can see all the questions in here, and you can contribute more questions, or if we want to pull some questions from something that we have. Again, like I said, we want to do that. All right, let's do a quick one. Quick 5 questions. Randomize the order. Yes, let's randomize the order. All right. This is our first question. Question number 1 for our KCSA. Which component validates and mutates Kubernetes API requests before they are persisted to etcd? So there's going to be a request coming from one of the tools that we use. Let's say we use kubectl, kubectl if you wish. And we write some command in there. Obviously, that command needs to be validated. Our identity needs to be checked. Do we have permissions to do that thing? And then one component will actually take the request. It will validate it, that we have the permissions. It will check that the request makes sense. And then, of course, it will persist that request to etcd. Which component is it? A, kube scheduler. B, kube proxy. C, admission controllers. Or D, kube controller manager. I'll give everybody a minute or two, or a second or two, to post their answers. Feel free, if you're on LinkedIn or YouTube, if you want to have a little bit of fun, answer in the comments, and in about 20 seconds, I'm going to answer myself. But while we do that, I want to remind ourselves, let me grab that link here. Let me grab that link. Let me grab that link from Kubernetes components. Kubernetes components was the link. Let me just quickly switch the screen here. Share screen. There we go. Kubernetes components. Kubernetes components, right? In the control plane, we've got the API server. That one basically handles all the requests relaying. We send the request to the API server. It forwards it to a component. And then, of course, nodes talk to the API server, and then they check their if there's anything. Scheduler will tell them if there's any changes in the etcd for them to apply, and scheduler will then talk to kubelet to create changes in containers. A kube proxy is the networking component. That one manages the network. Etcd is our database, and then controller manager is the one that runs the control plane. So if we go back to our exam question, all right. If we go back to our exam pressure, kube scheduler is a no, obviously, because that one just tells the nodes, hey, you got to do something. Kube proxies, the networking component. The mission controllers are the ones that control the pods, and then kube controller manager is going to be my response. That's the one that we have. Incorrect. Answer C is correct. Oh, the mission controllers intercept the API requests. Well, like I said, I don't know. I'm not 100% ready for this exam, like I said before. All right, so admission controllers, they validate or mutate requests. Resource quota, pod security, validating admission webhook. Okay, cool. Next question. Which of the following is the most effective way to detect abnormal container behavior at runtime? Regular vulnerability scans, Kubernetes audit logs for API server cars, runtime security tools like Falco and monitor syscalls, pod security standards enforcement. All right, we've got a question here. I wonder if you could convert questions from other tools such as Anki. Hey, questions, just a JSON file. So if you have other tools, we could probably do that. Yeah, not a problem at all. What I also want to do is I want to make this into like a nice web-based interface as well at some point. For now, it is what it is. It's just a command line. All right, so regular scans, yes, we could detect abnormal container behavior, and we should be doing regular scans. But what the question is asking is most effective way to detect them at runtime. Audit logs for API server calls, again, potentially we could, but then we'd have to be continuously, every time we run an application, we'd have to be looking at audit logs. Runtime security tools like Falco, at runtime, you could say that that's probably the right answer, and monitor syscalls to see what the container is requesting. And then pod security standards enforcement. Yeah, so pod security standards are going to enforce a barrier around the container. They're going to enforce that. They're going to make sure that the container doesn't have the privileges that it shouldn't have. But are they going to detect abnormal behavior? No, they're just there as a barrier, as a guardrail. So for me, this one is C, running tools like Falco. Yay! All right. I've read enough about Falco to know what it does. So yeah, detecting anomalies is done here. We got an explanation as well here. All right, question number 3. What is the purpose of the OPA gatekeeper in the Kubernetes cluster? to provide a key management service for encrypting secrets, to enforce custom policies on Kubernetes resource creation and updates using admission webhooks, to scan container images for CVEs during pod scheduling, or to authenticate users against an external LDAP territory. Hey, I don't know this one. I don't know this one. OPA gatekeeper. haven't read on OPA gatekeeper. I've been studying for a week. Yeah, this question above my knowledge. We're gonna go eeny, meeny, miny, mo. Eeny, meeny, miny, mo. Catch tiger by the toe. It's not an image scanner, is it? It's not an image scanner, is it? To enforce custom policies on Kubernetes resource creation. Feels like I'm gonna guess B. I got it right. Okay, so I was confident about question number 1 that the controller manager validates and mutates, but it's not. It's and then now I got it right. Guessing isn't wrong. Sometimes a good, well-educated guess is fair enough. Okay, so what is OTA gatekeeper? Uses validating admission webhook to enforce custom policies written in Rego. The policy schema, instances, require labels, deny privilege containers, for image. Okay, so okay, cool. So yeah, uses policies on resource creation. Cool. Learning. We're learning as we go. Domain. Overview of cloud native security. Which security model assumes no implicit trust based on network location and requires continuous verification of every request? Perimeter security, defense in depth, zero trust, security by obscurity. Now, obviously, this one is difficulty 2 dots. I would say 1 dot, to be perfectly honest. We're assuming no implicit trust. Answers itself here. It is zero trust. Zero trust essentially says, hey, every time a request is made, validate that request. Send some kind of credential, send a token, send username and password, send some kind of authorization, right? And this is essentially how OAuth works, how SAML works. The idea is that there is always some kind of a token or assertion or something that's happening that validates who is sending the request, so that we can then compare whether that individual or system or service has the permission to perform that request. And that's zero trust. Zero trust assumes no implicit trust. If I'm in the network, outside of the network, if I'm on the system, it doesn't matter. There should be no implicit trust when we're talking service to service. Perimeter security is about securing your platform at the perimeter between the private and the public area, scope, network. Sometimes private networks do have public components in there as well. So a public network is not necessarily the internet. It could be a private network that has publicly accessible services in there. Defense in depth, ensuring defense at every level. And security by obscurity, don't practice this. It's obscuring your applications or designs or components so that they're not commonly known, but an attacker will still go and beat that security by obscurity. So C, zero trust, assumes breach and verifies every request regardless of network origin. TLS, strong authentication, least privilege access. Yeah, that is the correct response here. All right, which of the following best describes supply chain security in the context of cloud native applications? Securing the physical hardware supply chain for servers. It's a good one. ensuring integrity and security of software from development through deployment, managing procurement of cloud service subscriptions, more supply chain effectiveness, encrypting data in transit between microservices. And now, you could say D is part of supply chain security, making sure that we are connecting to only encrypted services, or encrypted repositories, encrypted sources for your data. This is partially, but it's part of a larger scope of ensuring the integrity and security of your software. Like I said several times today, your container is built from potentially source containers, from some code, from some libraries, and that's supply chain security, ensuring that all of those components on their own are secure before we start patch them together and create our application out of that. So the correct answer is B. B, correct. Yes. All right. And that's how this one works. It gives you the wrong answer review at the end to make sure you know what you did wrong to drive that wrong answer forward. Cool. All right, B, to go back. And then let's take a look at the lab challenges. All right, so we have the lab challenges. Estimate the time it takes is, I would say, quite fair, maybe even on the lower side if you're starting out. So I don't know if I'm even going to keep that. All right, we're gonna do the first one. We're gonna do a role-based access control. All right, objective: create a namespace scoped role that allows reading pods, bind it to a service account, and verify the permissions are correctly scoped. And then your scenario here is: the monitor application needs to list and inspect pods in monitoring namespace, but it must not be able to create, delete, or access secrets. This is a core role-based access control leash period scenario tested on KCSA, right? And then we've got the tasks. So we're going to start with show tasks. Create a namespace called monitoring. Create a service account called pod monitor in the monitoring namespace. Create a role named pod reader in monitoring that allows get, list, watch, and pods. Create a role binding named pod monitor binding that binds the pod reader to a pod monitor service account, and then verify that service account can list pods but cannot list secrets or pods. Obviously, you got to have your cluster running, right? If you want, you've got hints, right? A few hints. Use kubectl, create role, pod reader. You got the verbs, resources, and you got the namespace, right? This is not the full solution. This is giving you some hints, and you also have the full solution. So your full solution, show the full solution, yes. All right. So these are the steps to be able to create that, right? And then it gives you the steps to clean up the exam itself. And then for validation, once you've done it, you've got your validation command. So you run these validation commands, and then it lets you say, yep, good. Now, what I really want to build is a way where the validation commands run from the platform itself, where you give the platform an SSH key, where it can SSH into your kubectl or your minikube or whatever you're running, and then it can run these commands for you. Or if you're running on a platform like Windows in containers, you're running minikube in containers, you could just say, hey, I'm giving you access to the minikube in this container that we're running. That's obviously a step that can be done fairly easily, but again, it requires a little bit of activity. So instead of show validation commands, we would just have number 4, validate, and then it would say, yep, validate, and then it would mark as complete for you. We also have the key concepts, right? Key concepts of the platform. I don't know, maybe I need to move the key concepts up, like into number 2 before the hints, right? Key concepts, because it is a learning tool. Key concepts probably should be higher up before the hints. So first you'd have tasks, then you'd have key concepts, and then if you need, you have some hints. Now again, these hints probably are a little bit too defined. So for example, here, basically, this is not just a hint, this is an actual solution, right? Create a role with the following verb setting would be a better hint. This is something that needs work. Again, this is version 0.0.2, early days, but I really want it to be a nice tool that I can use personally to prepare for these exams, and then of course everybody else can also grab if they want to play around with. Cool. That's all I wanted to talk about today. That's all I wanted to show you. It's going to be a little bit of a shorter stream today because we're at the end. I want to thank everybody for attending, for coming and seeing the session today. And I'll see you next Thursday, part 3, where I'm hopefully going to have some more features to show, some more capabilities to show, and perhaps even show some hints or lessons learned as I learn about KCSA. Obviously, I'm learning more lessons, and we can learn together. Cool. That is going to be it. Thank you, everybody, for watching, and I will see you next time. You're welcome. You're welcome. Yeah, I think it's pretty cool. And I think it can be even better. I think this is like early days, but I think it can be even better. All right. That is it. See y'all. Bye.